So again, I'd like to welcome you to today's TechNet webcast. This is Advanced SQL Server 2005 Integration Services. It's my pleasure to introduce today's TechNet presenter. We have John Weston here, and John is part of the Microsoft Across America team. So John, it's all yours.
Great, Janet. Thank you, and good morning or good afternoon or welcome to everybody. I'm out in the field today. Literally, not only do I live out in the field, we usually do these webcasts from remote Microsoft offices all over the country. I'm so remote today, there's not even a Microsoft office where I am. I'm in wonderful Burlington, Vermont, with about 2 feet of snow on the ground. They call it spring up here, and it's decided to rain today on top of all the wonderful snow we have outside today. I want to do a great shout out to my buddy Brian von Axelson, who's there in the scenes, behind the scenes. You can't hear him talking, but he's here on the webcast. So if you ask a question, he's going to do his best to look up through all the different resources we got and use all of his great own personal SQL Server skills to answer your questions you got. So go ahead and submit those questions. Now be patient with him. He's just one guy, and there's probably a couple hundred of you that might be asking questions today. So give him a chance. If he doesn't get to your question right away, he'll do it as quickly as he can. My information, as Janet said, I'm part of the Microsoft Across America team. I'm a TechNet presenter, going out and doing presentations around the Northeast today, and this week I'll be up here. My email address, if you want to send me an email question, don't have a chance to do it today, but want to send me a question later, it's jweston@microsoft.com or john.weston@microsoft.com. I also maintain a technical blog, and that blog is at blogs.technet.com/jweston. And one of the nice things that I like to do with that technical blog is put out some information after these webcasts. So all the questions and answers that you see down there in the little pane, I'll capture that information for you and post that up to my blog. Now, it does take me 2 or 3 days to go through and clean out names and all that kind of information from it. And also, I've been traveling a little bit, so it'll take me 3 or 4 days to get that posted up there. But I'll get that up there as soon as we can. Well, let's dive right into SQL Server Integration Services. Now, this is the advanced class of that, so let's talk about what we're going to cover today. We're going to cover 3 advanced techniques with SSIS, as it is for short. The first thing we're going to cover is using web services with SQL Server Integration Services. We have a number of questions in the past about how to use integration services within a web service environment. Organizations are now exposing more of their data and their business processes through web services, so it's natural to want to use these web services with our data integration processes. Next, we'll talk about text mining techniques with integration services. Much of the data we find out there in businesses today is unstructured. As we'll discuss this during the session, businesses need the ability to pull keywords and phrases from unstructured free text data and build warehouses, referencing tables, and other useful data structures from that unstructured data. We'll talk about how to use text mining within integration services to achieve some of these goals. And then finally today, the last demo or section we'll take a look at is how to use data mining within integration services. The ability to use data mining within integration services is one of the most compelling new features of IISS, and we'll discuss some of these business cases for using that. So what are the prerequisites for this course? This is a level 300 course. Being familiar with how SSIS data flows is familiar, and also familiar with a little bit of programming with some scripting. Something like VB scripting is helpful, but again, not necessary. If this is your first time listening to some type or watching an integration services webcast, you might want to go with the introduction webcast first. If you go out there to Microsoft.com/webcast and search for my name, John Weston, or search on SQL Server 2005, the last couple of weeks I have done what we call the IT Pro SQL 13 webcast, which is the Introduction to SQL Server 2005 Integration Services. So you may want to go watch that one first. For all those that were here last week or the week before with that one, appreciate you attending these and coming back for more of my webcast. So let's take a look at what our agenda is for this hour and a half that we got together today. First, we're going to look at how to use this web services with integration services, including the web services as part of a script component to retrieve and process data through a web service. After that, we'll take a look at how to do data mining with integration services and discuss why it's an important feature of integration services. And finally, then we'll look at how data mining tools directly within an integration service package, and then we'll look at the ramifications of being able to use this interesting new feature inside of integration services. So let's dive right into the first component. Web services and SSIS. If you spent any time working with integration services already, you may have noticed that there's a new web service task available for use in the data flows. A task is a part of control flow environment, a unit of work that either succeeds or fails as it performs a discrete operation. The web service task is for simple web service access. It simply passes a parameter to the web service method and then returns data from that web service in an XML format. Once the XML data has been returned, it can either be saved to a file or to a variable, or can continue to be used within the data flow. The web service task has restricted web service description language, or WSDL, so I'll refer to it as WSDL from this point forward, but it really is web services description language. The only simplest schemas can be used within this web service task. One of the reasons for that is that the web service itself is very complex architecture, and in order to create a simple integration service task that can go out and connect to a web service, we need to restrict the WSDL support within that task. The initial versions of SQL Server 2005 did not support the use of dynamic parameters within this web service method, but dynamic parameter support now has been included with Service Pack 1 of SQL Server 2005. You can use web service task as a data source by saving the XML returned by the web service as an XML file, and then using that file as a data source within your data flow. We also had customer requests for the ability to use the true full implementation of the web service as a part of the task. As we just mentioned, one step in that direction is the inclusion of dynamic parameter support within the web service task. Again, SP1 gives us that capability. There also has been requests to use the web service as a data destination in a transformation task within the data flow. The idea behind using the web service as a transformation task is that the rows are now coming through the data flow. You could call out the web service and execute the web method on each row that passes through the data flow. Using web service as a data source, as a data destination, and in the transformation can all be achieved in the data flow with scripting component. This is one of the main topics that we'll be looking at in this section. Preparing for our script component. As with any case when you're using a web service client, the first thing you need to do is download the WSDL file. When you get that file from the web service, the next step is to generate the proxy class. To do this, you invoke the WSDL.exe with the name of the WSDL file you downloaded and specify the output file to generate. In this demonstration, we'll see in just a minute, we'll actually generate the CSharp class, which is the default type class for the WSDL.exe to generate. Once you've generated the proxy class, the next step is to compile the proxy class into an assembly. The Integration Services script component is Visual Basic .NET component, but it's not restricted to calling assemblies written in just VB.NET. You can call any .NET assembly. In order to compile the proxy class into an assembly, you need the appropriate compiler available. For example, in the demonstration I'll use here in just a minute, we'll use the CSharp compiler csc.exe to compile the proxy class to the assembly. The CSharp compiler is included as part of the .NET Framework SDK that you can download from our website at Microsoft.com. You'll find the compiler within your .NET Framework folder. Once the proxy class has been compiled into an assembly, the next step is then to copy the assembly into your .NET Framework folder. Typically, when you compile from assemblies, you'll copy them into the directory the most recent version of the .NET Framework that you have installed on your system. Once you perform these tasks, you're all ready to use the web service with the script component. There are other ways to accomplish this, but these steps are the simplest, most reliable, and reusable ways of preparing the web service to use the script component. Now let's talk about how we can call the web service within our script component. Once you've created the assembly and copied it to your .NET Framework directory, the first step is to add the reference to the assembly to your script project. You do this by adding the Add Reference dialog box. Having done that, you can then add the instance of the web service with your script by declaring it. Once the instance of the web service has been added to the script by declaring it, you simply call the web service as needed within your script. And then finally, integration services. There are several ways you can use the script components. For example, you can use the script component as a data source. When using a data source, integration services will then automatically insert the template code for you. When using the web service-enabled script component as a data source, that calls your most frequently used in the create new output rows. Create new output rows is where the script component builds the output rows that will be pushed out into the data flow. In a web service-enabled script component data source, these rows will most often be the rows that are returned by the web service. If you're using a web service as a transformation, you'll write code to process the rows using the script component. If you're using the web service as a destination, you'd write special code to handle this as well. Let's take a look at a demonstration to see how this works. Enough slides, let's go and look at the product. In this first demonstration, you'll learn how to use SQL Server integration services to retrieve data from a web service. So I'm now going to go over to our application sharing. To view a full screen of what I've got, you may want to do the Control-H or F5. F5 will use as a toggle, so you'll remove all those other dialog boxes that you've got around the screen, and you can see full screen of what I've got running here. So in my environment here, I'm running Virtual PC 2007 on my laptop here, and I've created a virtualized environment with Windows Server 2003 Enterprise Edition. On that Enterprise Edition, I've installed SQL Server Enterprise Edition. And so one of the first things I'm going to do here is I'm going to open up the SQL Server Business Intelligence Development Studio. In this demonstration, we're going to take a look at how to use the script component as a source script in a data flow using a solution we've created beforehand. The script component can be used as a source, as a destination, or as a transformation. We're going to see how to retrieve data from the Amazon.com web service and integrate this information returned to us by the web service into our data flow. So I'm going to go up here and open up my pre-saved file. Now my voice may be up to 20 seconds behind or ahead even, depending upon if you're listening to me over the 800 number or through the internet over voice over IP. So I will try to go real slowly here and describe all the different click steps that I'm doing. So I'm going to first go out here, and these are some pre-saved files. These are not ones that come with it. So this is part of my SQL content that I've got here, my demo file. So I've created a folder called Demo Files, and I've built several different projects out here that we're going to work with today. In this first demonstration, we're going to work with our web services. So I've got a project that I had already created out here. So let me go ahead and open up that project. Okay, and so now you'll notice that that has been brought up into my Visual Studio Design interface here. So first thing you should look at over here is the Solution Explorer. Notice I could define my data sources, my data views, and this is the package that I've built. Okay, if you're not familiar with what a package is, that's a DTSX is our new one in integration services. Not the same thing as the old DTS packages. And so that's how we work through our different Explorer components. Notice there's some miscellaneous items that I'm going to work with in this particular one. And then I've got my design surface over here. This project consists of a simple data flow task, and if we look at the data flow task, we can see that it contains only two tasks. So I double-click on my data flow task, and notice it changes me to the data flow tab automatically. These two tasks are a script component and a raw file destination. We're using the script component as a source to retrieve the data from the web service and then send the output to a raw file. The raw file created then can be used as a source in another task or in another integration services package, as we'll see shortly. So let's drill into this script component. First, let's take a look inside the script component to see what's going on inside here. We have several output columns defined in the script component. It's important to note that we have defined these output columns manually. They're not automatically created. So let's go ahead and expand the output columns. So I have predefined each of these. Let's go and look at what I've defined. In the title of the output here, notice in the lower right-hand corner here, the data type properties. The title column is defined as a 400 characters, so 400 lengths long string, and the URL above it is also a string, but it is 1,000 characters long. We've also configured the manufacturer column to be a 255 character long string. The review column, which contains the full text product reviews on the Amazon.com website, is quite a bit larger than the other columns. Let's look at that one. Notice it is a Unicode. It is not a standard data string like the others, and its length is much longer. It is 4,000 characters long. In the script section here, you can see that some of the properties of the script But we want to go ahead and go into the script editing environment so we can click on designing our script. One of the things you need to remember, and I do this in all my webcasts, is I find myself not doing this all the time, is you want to always maximize things when you're in different screens inside of SSIS. So you'll see some different dialog boxes when you full screen them. So click on Design Script. And again, we want to full screen things so we can see what's going on here. The script editing environment is a Visual Studio for applications, which is a familiar, easy to use environment. To get this application ready, we've already gone through the steps outlined in the presentation. Okay, so we remember from the slides, we've already gone through the steps of taking the WSDL file from the Amazon.com website and use the WSDL.exe to generate the CSharp class from the WSDL file. Then we compile the CSharp class into an assembly by using the CSharp compiler that comes with the .NET 2.0 Framework SDK and move the assembly into the framework directory to make it available to this script. So let's take a look at the references we've got here. There's our AWSE Commerce Service. We've got our System.web service down here. Let me go ahead and close that Project Explorer and then also our Class Viewer panes so we can really see what's going on in the code here. Now we'll take a look at the script itself. A basic script is generated automatically when you first design the script, including the imports and the script main definitions. And notice here's all our imports. Those are built for us. And then notice we start off with our public class here of script main. And it's going to start off our dimensions. One of the first things we have to do is initiate the web service we want to use. Here we create the new instance of Amazon.com web service. We also create some new variables that are specified to the web service we used in the script. These variables are not created automatically and will differ depending upon the web methods that are available through the web service you use. So notice those start down here in the My ID, dimensioning those. The Create New Output Rows subroutine is created automatically by the script component, and we've defined some specific variables here. Since we're going to be working with the AdventureWorks database shortly, we're searching Amazon.com's web service for information on mountain bikes in the sporting goods section of their website. Now remember, mountain bikes is what we use in our AdventureWorks sample database that comes with SQL Server. So notice we're going to do the My Item Search Request title. Over here we're searching for mountain bikes. And that's going to be in the search index of sporting goods, and we're looking for a particular size of mountain bike, large. For each row returned by our search with mountain bikes, we want to add the row to the output filter. We do this by using the add row function. This is where the output columns that we specified are as part of the script component. We essentially take the title, manufacturer review, and URL of each mountain bike at Amazon.com and place those pieces of data into the columns in each row of our output. Then we pass this information along to the next task in our data flow. Again, since we're not connected to the internet for this demonstration, we can't run this task live and get the data back right now. But in a moment, we'll see exactly what the data script component returns from this task. We have an HTML file that contains the exact output produced by the script component we just looked at. So let's go over here and take a look at that file. That's under our miscellaneous files over here. We produced this by using the script component on the computer connected to the internet and sent the output to a flat file destination. The data returned by the Amazon.com web service component in the HTML code. We've got several rows of output that matched our search for the mountain bike, such as Mongoose Domain Mountain Bike. The text for the review is located to the right. The review will truncate the 4,000 characters since we define that output column only as a 4,000 character string in the script component. So notice here, there's a Mongoose 26-inch And I can scroll. You can see we get up to 4,000 characters here. Lots of good data that we pulled from that. If we search for the phrase Amazon.com, so to search within this text, I do a Control F to find, and I'm going to search for Amazon.com. And find next. Notice that it found Amazon.com, the URL here. So I'm going to close my Find and Replace dialog box, and there's the Amazon.com. If you're able to access the web service live, you could integrate the data, return directly back into the data flow, so you could perform the lookups and other tasks as we'll see in the next demonstration. Go ahead and close that component. Now we've seen that file. We'll also take a quick look at the CSharp class created by the WSDL.exe using the WSDL file downloaded from Amazon.com. So let's open that one up right here. So this is kind of beyond the scope of this demonstration, but this gives you an idea of what the class looks like before you compile it with the CSharp compiler. It's going to give you an idea of what's out there. We're not going to go into all details of what is in this. But as you can see, it's quite a large piece of code. Let's go back to our data flow. Let's take a look at using the web service task. So I want to first go back over to my control flow. And at the left side of the screen, I'm going to point to my toolbox here. And I want to find a web service task and design, and let's drag that onto my design service. Whoop, come back here, toolbox. And let's go find a web service task. There we go. Drag it onto the desktop, onto my design surface. And now let's go into that web service task. And again, don't forget to maximize your windows. There we go. And I'm going to look at my HTTP connection here and do my little drop-down box, and it'll allow me to create a new connection. And so I want to create a new connection here, and I got to get real specific to do my typing of my URL here, so I need both hands to do this. My headset wasn't compatible with the hotel system I'm in today, so I'm having to hold the phone and try to type at the same time, and that's always a lot of fun. So we're going to do http://webservices.amazon.com/AW, need to capitalize these, AWSE, commerce server, commerce services, excuse me, commerce service /AWSE, commerce service.wsdl. Now, couldn't somebody come up with a shorter file name for me next time? Okay. I could test the connection area if I was live connected, but we're going to go ahead and click OK there. So we've already downloaded this file from Amazon.com, so we can look at and tell the web service task where the WSDL file is located. So here I'm going to go ahead and on the WSDL file, I'm going to click on the little ellipse next to it, and we're going to point to the location where that can be found. So I'm going to need to navigate to that. So let's go ahead and see if we can go to C drive, TechNet content, SQL 14, demo files, web service. Oh, there it is right there. Okay, so notice it gives the path all the way out to it. And I can overwrite that file if I want to. The overwrite WSD file setting specifies whether the web service task should overwrite the existing WSDL file. We're already downloading the latest version from Amazon.com web service to the WSDL file, so let's leave that set to false. If we know that there's an update to the WSD file that we need, we can set this value to true and then click on Download WSD file button to retrieve the new version and overwrite the existing version. If you haven't already downloaded the WSD file from a web service, you should set the overwrite WSDL file to true, and then click on Download WSD file button in order to get the next version of the file stored locally before you first run the web service task. So let's take a look at our input here. Next, we're going to specify the inputs from the web service task. There's only a single service available to us, AWSE. Okay, so let's go ahead and click on that and specify the AWSE Commerce service. There we go. Next, we'll need to pick the web method that we want to use for this task. We'll specify that we want to use the item search web method that we used in the script component. So notice the different options that we've got here, but I'm going to use item search. After we set the input parameters, we need to specify the type of output we want to use for the web service task. The only two types of output available for the web service are file output and variable output. So click over here on output. We've got file output and variable output. Oops, excuse me. Let's do variable in this case. We'll create a new variable to store the data in, and when we're done, we'll create a new variable called user variable that will hold the output of the web service task so that we can use another task to get that data from the variable we use in the data flow. So here I want to click on the cell next to variable, do the drop-down box, there we go, new variable, and this opens up my add variable dialog box. And this will leave all that alone. It'll be a string, that's good. So there we've got user : variable. All of that looks good. And that's all set to go. So that concludes our first demonstration. So let me go ahead and close that project out. Let's go back to the slides for a few minutes. So in that demonstration, we looked at using a script component, viewing the script component details, and using a web service task within SSIS. So back to our agenda. We're a third of the way through. Next, we're going to take a look at text mining in SSIS. One of the primary reasons text mining is so important that currently less than 20% of the world's data is stored in structured format, such as a relational database. Most of the world's data is actually stored inside text and business documents. The goal of using text mining within integration services is to get to and retrieve meaningful information from that unstructured data. There are several important aspects of the core text mining technology inside of integration services. When text mining within integration services, that incoming data that we look at has to be one of the two types of data, either DT wide string, a Unicode data type, or in text column. Even if your data isn't currently stored in a Unicode format, you can easily convert to Unicode format within Integration Services Dataflow task. Another important point is that you can use algorithms to extract only nouns and noun phrases, and those that are most common things you want to look at for whenever you're doing text mining. At this time, text mining only supports the English language, but the architecture is extensible, and will add the support for other languages in the future. You can also select the limiters in term length. That is, if you're looking for a phrase, you might want to search for the term bike in a 4-letter phrase, or you might want to search for the term mountain bike as a much longer phrase when performing text mining within integration services. You need to set your delimiters and term length relevant to the data you're looking for. The text mining components of integration services store according to the frequency within which it occurs. Two types of scores are used. The most basic score, two types of scores are used, The most basic score is a frequency score, which is just the count of the number of times a term appears within your data set. This is also a more complex score called the TF-IDF, which is a score based upon the number of times a term appears within a single row and the number of rows which are throughout the entire document that contain that term, which is a useful measure when you're trying to calculate the frequency of a term across the entire data flow. The first component is called the term extraction component. This component takes incoming data, finds key terms, and then passes them to the output. For example, the term extraction component would extract all the key terms in a document like bike, mountain bike, aluminum frame, and so on, and send them to the output build to a reference table of the terms from the known document. You could also use this to find key terms that appear in the resumes of such successful job applications. To do this, you might want to use the resumes of current employees, including them in a data flow with the term extraction component, and then use this as a reference table to compare to the incoming resumes of fresh job applications against. This may help you reduce the number of job applicants you need to search before finding promising candidates. You can also use fuzzy grouping to deduplicate similar terms such as bicycle, bikes, bike, and bikes, which you may want to consider as a single term. Now, we're not going to cover fuzzy grouping today. We did cover fuzzy grouping logic in the first course. Text mining components. The companion component to the term extraction component is the term lookup component. We have a lookup table or of key terms found in the resumes of current employees. The term lookup component can be used to determine which of these terms are found in the incoming through the resumes of new components. When you use the term lookup component, be sure to pass through a key column in order to be able to identify the incoming document. In order to make sure you select through the resumes that have terms that match your reference table, you need to send a key column through so that the new incoming resumes have been analyzed with the term lookup component. You'll be able to go back through and find incoming resumes that have terms that match the reference table of existing employees. All right, back to time for demonstration. In this second demonstration, we're going to take a look at text mining within SSIS. Here, we're going to take a look at find interesting terms, perform term lookups, and view text mining results. So I'll go back over to my sharing machine. Remember, F5 is your toggle. So F5 will take you to where you can see my full screen. I've got another pre-saved project out here. So I'm going to go over to File, Open, Project or Solution. And we're going to look in our text mining ones. There we go. In this one, we're going to take a look for those terms in our information that we retrieved from Amazon.com web service in our last demonstration. There are two flow control tasks within this package. The first finds terms in the AdventureWorks database that we believe are interesting and then creates a reference table from that. The next package then takes the output of the web service task we ran earlier and compares the words and phrases to interesting terms in the reference table so that we can find what products on Amazon.com are competitors to AdventureWorks products. Okay, so I've got my text mining package here with my two different components. Let's first go into my find interesting terms on AdventureWorks. The data source sets for this task is the product description table in AdventureWorks database. So notice I've got my product descriptions. I do term extraction, filter out any abbreviations, find interesting terms, and then finally output to my SQL Server destination. Once we've extracted the interesting terms and filter out any abbreviations, we load the resulting term into a SQL Server table. This becomes a reference table that we can use in the next control flow task to find the competing products in Amazon.com. Let's go in and just take a brief look at what we're going on here. So I've double-clicked on my product descriptions. As we noted, we're going to look at interesting terms in the product description table. You can preview this data. So click on the preview button here. And I can see the data from my data source. We've got a list of products that are detailed descriptions from the database. This table looks like a good candidate for finding words and phrases for our text mining operation. Notice the description field here. From the data source, we're going to use the product description ID, description, and row GUID columns in our data flow. Okay, so notice we're picking up those three different columns. Oh, can't get to my cancel button. Why? Because I didn't full screen things. There we go. Next, let's take a look at our term extraction. Columns we've selected from the data source are passed to the term extraction task. When performing these task extractions, you'll have to specify a single text column to use as the input for the task. We're going to use the description field. As you can see here. Let's take a look at our Advanced tab here. We're extracting both nouns and noun phrases from the description field. We also have a choice of scoring method to use. One is a direct score, the number of times that term occurs in our data set. However, we're going to use a scoring algorithm called the Terminal Frequency Inverse Document Frequency, or TFIDF. So I select that here. Next, we see the frequency threshold so incoming nouns and noun phrases that occur at least once in the data set are extracted. The maximum length of the term we're extracting is 30 characters. Depending upon your application or data set, you may want to adjust these to include only terms that with a higher frequency or those that have a longer or shorter maximum length to improve performance. We also have the option to include certain terms from the term extraction task. If you have a database table where your terms that you don't want to include in the output of your term lookup task, you can enable this here and specify the tables. We're not going to use this exclusion terms here, so we'll just leave this as disabled. Back to our Dataflow task. Once the term extraction has found all the interesting terms in the product descriptions, we want to clean up that data by doing filtering out abbreviations. So let's take a look at what goes on there. We'll do this by using a conditional split. A conditional split allows you to define different outputs and criteria. Data meeting specific criteria is sent to an outputs you define. The different outputs from the conditional split can then be routed to different Dataflow tasks. Notice interesting terms here, length of the terms got to be greater than 5. We define only one output here so far. The output is called interesting terms and is defined as any term greater than 5 characters in length. While we're using only a fairly simple example here, you can perform splits based on any number of different variables and functions. We have several system variables we could use in creating from the splits data. We also have several math functions. Let's look at the different variables we have at our disposal. And then how about all the different math functions I could do against those variables? After performing the term extraction, we move to the next control flow task to find the competing products from Amazon.com. So let's go back to our control flow, and let me resize this one so you can actually see the description. Not move it, just resize it. There we go. Find competitors from Amazon. In this demonstration, we saw the Dataflow task that accessed the Amazon.com web service, retrieved the data from about mountain bikes, and then sent the data to the raw file destination. Here we're using a raw file created earlier as the source for the Dataflow task. Again, we don't have internet access here, so I can't go on much further. So we aren't able to show the exact facts. The data source included for the product title, manufacturer, review, and URL for the product. Taking a look at the data from the raw file, we look up from the terms and the data that match the terms in the interesting terms reference table we created in the previous flow. There, we're performing the count on how many of our interesting terms appear in each row in the Amazon.com. We're then sending that information to the database destination. So if I had connectivity here, I would actually run this one for you, but since I don't have that, I can't show you the results for that. All right, that concludes demo number 2. Let's go ahead and go back to our slides here for a minute. So in that one, remember, we took a look at finding interesting terms in our own database, performing a term lookup, and then viewing those results from our text mining. Grab a drink of water right quick. My throat's getting a little dry. right, I'm back. So third section here, we're going to take a look at data mining with SSIS. Mining models are built and deployed with analysis services. You can get more information about data mining models and analysis services by looking at the Sample Analysis Services project available with SQL Server 2005, reading some books, or viewing some additional webcasts that Brian and I have done in the Business Intelligence series, discussing analysis services and data mining. Brian von Axelson's there answering all your questions. And behind the scenes, I see he's got the questions down to 0, so thanks a bunch, Brian, there for being there behind the scenes. You can use integration services to process and train the mining models that have been built and deployed with your analysis services. You often need to populate the mining models with more data and process it to find patterns within the data. These are the things you can do with inside of integration services. Interesting, though, you can also use integration services to query the mining model. You can do this by having the data mining integrate directly within the integration services in the Dataflow process. At design time, integration services can be used to deploy mining models or analysis services data in mining projects. At runtime, integration services can be used to deploy and process mining models. This is an important distinction to keep in mind that when using data mining with integration services, while you can design with a deployed mining model or a data mining model project, at runtime the data mining model must already be deployed and processed in the analysis services, in order for integration services to be able to use the data mining model on the analysis services. So in preparation for this last demo, I went out there and went ahead and processed my data mining model before we began today. One of the reasons you might want to use data mining within a data flow is to impute missing data. For example, if you have an unscanned item, when you know that the price and the weight of that item, but you don't have the barcode scanned, data mining could be used to predict what the barcode value should be assigned based upon the weight, price, and other information that you have on that individual product. You can also use data mining model in a data flow to help identify bad data. For example, anomalous readings from equipment logs that fall outside the range of acceptable values. It can be complicated to write a set of rules to describe the range of acceptable values because there might be so many different parameters. With data mining, though, you can compare incoming readings to a known good set of readings to help determine anomalies. You can also, for example, detect mistyped age or price fields with data mining integration services. The product in your database could be entered with an extra 0 on the end, increasing its price to 10 times the correct price. When comparing the use of a data mining model to search for patterns, you can detect this product is incorrectly priced based upon the prices of similar goods in the product's database. You could also infer complex business rules, such as identifying customers with attributes lying outside what are known as clusters. We'll look at this more specific ability in our upcoming demonstration. First, you need to select the mining model and structure. You need to select these either from an analysis server where they are deployed or from an analysis services project in your business intelligence solutions. Once you've selected the mining model and structure, you need to build a query with the data mining query language. The data mining query language is straightforward, and within BI Development Studio, you have a visual query builder, which allows you to map the data input columns to the mining model. When building the query, you also have to select the predict column. This is the value you're trying to predict based upon the existing data. For example, you might want to predict what people on a mailing list are likely to buy bicycles based upon what you already know about the people who've purchased bicycles before. In addition to selecting the prediction column, you should also select the metric from the prediction function. The predict probability function is one that you'll find useful because it gives you a quantitative measurement of how confident the mining model is that that person is likely to buy a bicycle. With this, you can rank the customer's order of descending probability and target only those customers who are most likely to buy a bicycle. You should also pass through any columns that you need to have further downstream data flow. And you should also remember to provide the useful column names when designing your data mining query. We'll see more about that in our demonstration in just a second. Let's consider a sample integration services data flow. We're starting two different data sources, A and B, and using integration service tasks to merge those together from the two different sources. Once the data is merged, we'll perform a prediction based upon that data. The prediction is done by querying analysis services. We perform the prediction by connecting the mining model that's deployed as a process analysis services and passing it to the data we're already merged together in the Dataflow. Analysis services will analyze the data and predict the probability based upon the data already presented in the mining model. Once the analysis services have made the prediction about each row of the data, we can further process this data by splitting it into good data and bad data. For example, we might want to split our data into two destinations. One destination for people who exceed some probability value threshold that indicates that only they're likely to buy a bicycle, and those who fall below that predicted threshold. From there, we can target only those people who are at or above the threshold. This allows us to focus our marketing efforts on those we believe are most likely to buy a bicycle from us. As mentioned earlier, we can use the data mining and integration services to infer complex business rules, such as identifying customers with attributes that fall outside our known clusters. Let's consider clustering model of customers in the database. These are three identifiable clusters: low-income young people, low-income older people, and high-income middle-aged people. When we identify these clusters, we can use the mining model that knows about clusters to evaluate the incoming data. We have three new people in the data: a young person earning a great deal of money, a middle-aged person earning a very low income, and an older person with significantly higher income than the other people in the age group. These three people don't fit within any of the clusters that the mining model knows about, so we can easily identify them as outliers. Knowing this, we can do something important with them. We can filter them out for further examination and try to determine whether the data is inaccurate, whether it represents someone perhaps trying to overstate their income in order to obtain a mortgage, or perhaps just a problem with the data. To draw up a set of business rules to identify the outliers can be complex, but data mining can easily help identify them. So let's go take a look at our last and third demonstration. In this demonstration, we're going to take a look at data mining with use inside of integration services. So one last time over to my demonstration machine. Okay, remember F5 is your toggle to take it to a full screen. Oh, we forgot to close out this last project we were working on, so let's go ahead and close that one. And we're going to open a new project here. And this one's going to be a data mining project. So as you can imagine, I've already got one built out there for us. This one is going to take a look at the potential AdventureWorks customers using a data mining model to determine which of these potential customers is likely to buy a bicycle. We're using a simple Dataflow task with only three components here. Let me resize my screen a little bit. There we go. An Excel spreadsheet is our data source with our list of potential customers, a data mining query task, and a row count task. Let's first take a look at the data that we have in our Excel spreadsheet. So I'm going to go over here to my Solution Explorer, and there's my customer leads.xls. This consists of the kind of data you might purchase for the purpose of expanding your customer base. This spreadsheet contains the name information, income information, some other demographic information such as marital status, gender, children, and other information such as car ownership and commuting distance. What this doesn't tell us is whether or not this customers have the indicated an interest in buying a bicycle, and that's what our data mining task will help us determine. So now that we've seen the sample data, we can go ahead and close that. Now let's take a look at how the data mining query task will help us process the data in the Excel spreadsheet. To perform the data mining, we're going to connect to an existing analysis services cube, AdventureWorks DW. The analysis service cubes contains a mining structure called the targeted mailing that we're going to use. In turn, the target mailing mining structure contains several different mining models that we might want to use. We're going to determine to use the decision tree mining models for this demonstration. So notice I've already got decision trees highlighted here. Let's go to the query tab so we can take a look at this query. We'll see the text for the data mining query that we'll run. You can type the query in manually here, but you can also use the designer to create the query visually, which makes it much easier. Let's take a look at the Build New Query. This is our query designer. We've got several of the input columns from the Excel spreadsheet data mapped to the columns in the mining model. Let me resize this so we can see more of our code down at the bottom. There we go. In this query, we're specifying that we want the decision tree mining model to predict the value of the bike buyer column. The possible values for the bike buyer column are 0, indicating that the person is unlikely to buy a bike, or 1, indicating the person is likely to buy a bicycle, according to the data mining model. We also specified 2 additional prediction columns. The bike buyer column can only have the values of either 1 or 0, but the predict probability and the predict support functions provide more quantifiable scores that we can score likely the bike buyers according to the probability that they will buy a bike, again, according to the mining model's prediction algorithms. We have quite a number of functions available to us here. Lots of these functions can help us perform predictive analysis within your mining model and help us redefine your results based upon your business needs. Let's move on down our flow task. The row count is our useful task. It counts the number of rows that come into a task and then places the number into a variable. One of the interesting things about the row count task is that you can use it at the end of a data flow. We're using it here at the end of the flow so that we can not only get a count of rows, but we can also see the results of the data mining query without having to load the results into a table or a file. Notice my custom properties here, variable names if I want to specify that. The variable that the row count uses has been defined within the scope of the Dataflow task. You can create variables throughout the SSIS menu. So let me go ahead and show you how to do that. We'll click Cancel here. We'll go to our Control Flow tab. And we'll click on our Dataflow task. And notice if I have my menu up here, I go up to the SSIS menu and Variables. This Variables dialog box, we see 2 instances of variables. First, we see define the variable within the scope of the Dataflow task. Next, we see that the variable is actually used within the scope of the row count task. And when I do that, it always resizes my windows. Let me refix my display here. There we go. Let's add a data viewer here before the row count task so we can see what data is coming out of the data mining query. So remember how to add those from our last session? Right mouse click, data viewers. I'm going to click on add. We'll just do a standard grid one here. Oh, I'll tell you what, let's modify it. Let's not just do a standard one. What do I want to do? Let's do grid and click on the grid tab. Now let's get, notice it's defaulting to all of those fields. I don't want all of those, so let's get rid of that. And let's add back first name to supplier. Put those in. So now my data viewer is only going to show me the columns first name, last name, bike buyer, probability, and SUPP field. So much easier to view once we run this. Now that we've got our data viewer, let's go ahead and execute this package. There's our wonderful little query window. So let's move it around here so we can see how things are going. So there, notice we've got 3,912 rows so far. First name, last name, bike buyer 1 or 0. Notice our probabilities here. And the SUPP columns. Well, let's let this package continue to execution. So click on Continue, close our data viewer window here. Kind of resize some of the windows here. Let's go ahead and close that output window. We can see that we had 40,000 rows execute. Let's go ahead and stop that debugging. That's a lot. I don't know that I got money to do marketing to 40,000 people. So, boy, I'd sure like to pare that down a little bit. Next, let's do a little bit more with our data mining from our data mining task. First, we're going to remove this row count since we no longer need that one. So highlight that and delete it. Yep, sure I want to do that. And now I'm going to go over to my toolbox and let's define a conditional split, bring that out to the design surface here. Okay. We'll connect this output of the data mining query. So highlight my data mining query, grab that green arrow and put it down to the conditional split. And let's go in and define our conditional split. We'll create our outputs and criteria for our conditional split. So here I want to expand my columns. And I want to take bike buyer and drag that down to my first condition here. And well, I only want to see people that are going to buy bikes from me. So I'm going to do equal equals has to equal 1. And output, we're going to call that, instead of case number 1, we'll call this one, oh, need both hands again here on the phone, bike buyers. There we go. That looks good. Oh, didn't full screen again. Can't see my OK button. And OK there. Now we've created output for likely bike buyers. We'll connect it to our database. Let's see, I've lost my place here and exactly what I need to do next. Oh, I see. I need to connect that to my database, so we need a database source. Let's do that. So drag my OLDB, that's not database destination, excuse me. So there we go. Drag my database destination onto the desktop. And now we need to connect that to our conditional split that we just did. So we take my green arrow here and drag it down there. Whoops. There we go. So the output dialog box appears. And this is when I have bike buyers. I want them to go to my OLD destination. So now let's define what is our OLDB destination. And let's use our connection manager. Create a new connection here. Make sure I'm on my right SQL server. Yep, that's the one I'm using here. Let's create a new table. And so instead of OLDB destination, I got to give my file name a name that we want to output all this information to. And we'll call this one likely bike buyers. So I'm going to have me a nice SQL Server table when we're done here. And click OK. And I can preview that information if I want to. That looks good. And go ahead and what am I missing here? Oh, I need to do my mappings. That looks good. And now we can click OK. So let's start our debugging. Now, you think we're going to get all 40,000 users this time? So remember, our original source had 40,000 rows of data in it, so we're almost done crunching through them here. Here we go. 40,000 made it through that. 27,000, oh, we're still doing our data mining query. And it looks like I'm going to end up with somewhere around 13,426 potential bike buyers. So this allows me to map that conditional environment after doing my data mining, mapping it against this Excel spreadsheet I got, and then my output of this has created me a database with potential bike buyers in it. Let's go see if it actually built that table or not. I'm not sure I connected to the right server here, but let's double check right quick and see if we can't see if that was on this server or did I put it over on my other server. Instead of analysis services, I want to connect to my database engine. And this will take just a second or two here for this to load. Databases. I think we put that in VentureWorks, didn't we? Tables. I must have put it over on the other server. Or was it a data warehouse? Let's look. There they are. I put it in the data warehouse. So there's my data. Okay, it's got all my wonderful information that we want there. And see if it's going to let me open that. Nope, because I put it into the data warehouse, it's not going to let me view the table here. I put it over into the wrong one. Sorry about that. No big deal. But you get the idea, the concept. All right, so in that demonstration, we took a look at selecting a data mining model, performing data mining, and then sending the data mining results to a database, or in my case, I actually sent it to the data warehouse. You see today with integration services allows you to implement solutions that go far beyond traditional ETL functionality, allowing you to use a number of interesting and important new data sources and destinations that perform complex operations on that data with the data flow. The ability to use a web service within integration services is a great new feature that allows you to get the data directly from the web service and integrate it into your data flow with a scripting component. And then finally, we've also seen some of the really powerful things you can do with the text and data mining features of SSIS that allow you to extract meaningful information from unstructured data, performing predictions and finding anomalous and incorrect data, all within your integration services package. Wow, we made it to the end. So Janet, I'm going to turn it back over to you and check and see how Brian is doing on those questions.
Excellent. Well, great. And that being said, I just want to let everybody know that we do have lots of great information posted throughout, and you can actually get a copy of these slides. Just go into your file menu in your upper navigation bar, and you'll be able to do a print PDF and get all of these slides that have been available today. So with that being said, we do have a survey coming up here. But before that, I want to remind you, if you have questions, go ahead and submit those now. I know Brian's been doing a great job answering your questions throughout. We'll take just a moment here to wrap them up at the very end. We do record these webcasts as well. So if you'd like to see anything that's been previously recorded, as well as anything that is coming up, everything's posted right there at Microsoft.com/webcast. If you have content ideas, anything you want to see us do differently, we'd love hearing from our audience. There is yet another URL there where you can contact us and let us know what you'd like to see. And then I'd just like to let you know that today's webcast was presented using the Microsoft Office iMeeting technology. There's a free 14-day trial. All you have to do is go to Microsoft.com/presentlive and you'll be able to get that. As I mentioned, we do have a survey coming up here. I want to remind you all that your feedback is very valuable, so if you could take a moment to fill out the survey before you log out, we do appreciate that. For doing so, you'll be automatically entered into a drawing to win this great little Zoom digital media player. So it's a little bit of an incentive there, but really, we do like to get your feedback, and we do pass it on to our presenters. So if you have any comments there for John, go ahead and submit those into there as well. And with that being said, John, any questions that you want to go over before
No, it looks like Brian has done a super job and answered them all behind the scenes, so great. Appreciate him doing all that. And again, if you don't get a chance to ask us a question here, don't hesitate to email either Brian or myself. Again, my email is jweston@microsoft.com, or go out and check either one of our blogs. We'd love to hear from you.
Excellent. And so with that, we'll just we'll remain online for just the next few minutes, and we'll capture any of those additional questions that come in. As John mentioned, he does put those on his blog, so you can always check back there, see any of those questions that have been asked throughout, and we can get those posted there. So with that, I'm going to extend a special thanks to John for today's live meeting. I'd like to thank Brian for hanging out in the back end there and helping out with questions. And I'd like to thank you all for joining us. So you may now all disconnect from the audio portion of this event.